All right, friends, hello and welcome to today's edition of the Pwn Physics 365 podcast, where we are doing physics every single day of the year. And today, Monday, February 8th, Super Bowl is over. Looks like Denver won, just in case you are elsewhere and wondering how it turned out. But we are actually going to turn our eyes elsewhere today because we have a very special on this day in physics, and so let's take a look. The 8th of February, 1700, we say happy birthday to Daniel Bernoulli, who was a physicist and made large contributions to the field of fluid dynamics. He is also the Bernoulli of the famous Bernoulli Principle and Bernoulli Equation, more below. So, let's take a look at our word of the day, which is the Bernoulli Principle. The Bernoulli Principle is something that describes fluids in motion or flowing. Imagine fluid flowing through a pipe of a certain radius. It will have a certain pressure and velocity since it's moving. If this pipe was to narrow, the surface area and radius decrease, right? So the velocity of the fluid will increase. But what about the pressure? The intuitive response is that the pressure increases. However, what Bernoulli tells us is that the pressure at this bottleneck is actually lower. What the heck? How can it be? Well, Bernoulli's principle is sort of just another expression of conservation of energy, or Newton's second law. Because the velocity increases, there is no increased energy being injected into the system. And as the Grateful Dead say in their song New Speedway Boogie, something's got to give. And that thing is the pressure. So the pressure goes down in order to even out the increase in velocity. A phenomenal example of Bernoulli's principle in action is a perfume atomizer. How does it work? Well, you have this bulb full of air traveling at no speed whatsoever, so the air is just sitting in the bulb. And then at the top of the perfume bottle, there's a small tube or straw which runs down into the perfume. When you squeeze the bulb, what happens? The air is a fluid, by the way, moves very quickly out of the nozzle, and what happens is that the pressure in this area goes way down. The liquid and bottle, now at a higher pressure, react by pushing the fluid up the tube and into the nozzle. The air, also moving quickly, pulls the liquid off in tiny little beads, which then make a beautiful perfume vapor in the air for ladies everywhere to enjoy. So that is Bernoulli's principle at work. Another way of thinking about it is if you have a hose, right? You're watering your lawn, you don't have a nozzle on it, and you can't really get the reach you want while you're watering the lawn, and you put your thumb over it, it sprays out like crazy. And so actually what happens is that the pressure where your finger is, the little hole that's left, goes way down. But the velocity goes way up, and that's what causes the water to shoot every which way. So, anyway, that's a little bit of Bernoulli principle, and I actually have a quote from Daniel Bernoulli, the birthday boy. So we have a 3-segment trifecta, everything Bernoulli today. But he's a pretty heavy hitter in terms of physics and fluid dynamics in general. So he gets one day of the year, I think. So let's take a look at his quote. Nature always tends to act in the simplest way, which is really true. It may not be the most intuitive to us earthlings, but it is usually the simplest solution. So there we go. That's Bernoulli's principle. Happy birthday, Daniel Bernoulli. And I think that's going to do it for today, guys. So as always, thanks for tuning in. Putting me in your headphones, and head on over to the blog, pwnphysics.blogspot.com, to dig a little deeper. And for links to my physics review iPhone apps, which are very, very handy, and there may be 1 or 2 or 3 coming that are directly related to this podcast. So stay tuned for that. And with that, I think I'm just going to say, I'll see you tomorrow, guys. Until then, rock on. Physics. Peace.